Penicillin production. So the first step in the production of penicillin is development of inoculum. So the inoculum which is used in the production of penicillin is prepared like this. First, the spores are suspended in water from the stock culture of Penicillium strain, and then it is mixed, which is mixed with surface active agent, so that there will be formation of a homogeneous suspension. So these sodium lauryl sulfonate, it is used as a surface tension reducer that makes possible to form a homogeneous spore suspension of penicillium. This is then inoculated into flasks or bottles, which are of course sterile and containing sterile nutrient solution. The generally used nutrient solution is wheat bran. So this wheat bran medium, it is inoculated and then incubated at 24 degrees Celsius for 5 to 7 days. So this leads to the heavy sporulation. So the multiplication and propagation of penicillium, it takes place through formation of asexual spores. So this spore inoculum is now ready, and then the spores are used to inoculate inoculum tanks. In inoculum tanks, it is incubated for 24 to 48 hours containing the sterile nutrient medium, along with agitation and aeration in order to get heavy mycelial growth. So this spore is used to inoculate inoculum tanks in which the spores will receive the nutrients and it will germinate to form heavy mycelial growth. And then the resulting mycelial inoculum is inoculated into a second or third stage of inoculum tank, depending on the capacity of production tank. So this is how the inoculum development process, it starts with spores and it ends with formation or obtaining heavy mycelial growth. Now this heavy mycelial growth, it will be used as a mycelial inoculum for the inoculation of production tank. Now the important part is the incubation conditions. So the incubation temperature is 25 to 26 degrees Celsius and the fermentation may last for maximum 5 days. Now the important component is the composition of production medium. In general, the composition of the production medium, it is not easily available in the literature. So whatever the composition of the medium that the industries are using, it remains as a trade secret. So the composition which is given here, it is a general composition which is available in literature. So let us see what are the principal components so that we can understand the composition of production medium and their essential roles. Constip liquor. Then constip liquor is in 3.5 gram percent. Then there is a disaccharide, that is lactose, 3.5 gram percent. Then a monosaccharide, glucose, 1%. Calcium carbonate, which acts as a neutralizing agent. Potassium phosphate, edible oil, which acts as antifoam agents. And the most important is penicillin precursor. Now you can note the difference between production medium and inoculum development medium. Here, production medium must contain precursor. Inoculum development medium, there is no need of addition of precursor because penicillin fermentation or production, it is a precursor dependent fermentation. Use of precursors increases the yield of penicillin. The final pH of the medium is 5.5 to 6. Now, after inoculation into production tank, whatever the events that happen, whatever the changes that happen during the fermentation, it is called as course of fermentation. Means it is the time period of fermentation during which different changes takes place during fermentation. So this is also called as time course of fermentation. Now whatever the events that happens during penicillin fermentation are divided into different stages. In the first stage, at the start of the fermentation, so we know that glucose is there in the production medium. So glucose and carbon compounds from constip liquor, they are utilized during the first stage of growth. So mycelia, they rapidly utilize glucose and carbon compounds which are easily metabolizable and which are present in constip liquor. So they are utilized first, and this leads to the growth of fungal mycelium. So the mycelia becomes thick, and this period is from 20 hours to 30 hours. During this period, the pH of the fermentation broth, it remains constant. Next, in the second stage, after the depletion of glucose, amino acids from constip liquor are deaminated and that liberates ammonia. So the first preferable carbon source is glucose, and once the glucose is exhausted from the medium, the mycelia will look for the alternative sources, and the alternative source is amino acids. Utilization of amino acids will lead to formation of CO2 and NH3, that is ammonia. Due to the release of ammonia, the conditions will become alkaline. That means the pH of the fermentation broth will rise. It will rise from 7 to 7.5. This is the optimum period, or this is the optimum pH for the production of penicillin. So the synthesis of penicillin starts in this phase, and maximum is achieved at 48 to 96 hours or 4 to 5 days. Now during this production phase, lactose is utilized. So in the initial step, there is utilization of glucose. In this phase, there is utilization of lactose, which is accompanied by the production of penicillin. So lactose is a disaccharide and it is degraded to glucose and galactose. And then this glucose and galactose will be further metabolized by moles. So obviously lactose is slowly metabolized. This slow availability of glucose, it generates starvation conditions required for production of penicillin. That means this causes a nutrient stress, and this nutrient stress is essential for maximum production of penicillin. So mycelial growth is very little during this period, but there is maximum synthesis of penicillin. So at this point, the mold is at starve condition. In this phase, the pH also remains constant at 7 to 7.5. In the last phase, at the end of fermentation, that is approximately 46 to 4 to 5 days, the pH of the medium it increases and it goes beyond 8. This higher pH is due to depletion of lactose. Now lactose is finished from the medium and the cells will start getting autolyzed. So autolysis of cells, mycelia, it will lead to release of ammonia which is there in mycelia. It will be released in the medium and the medium's pH will increase to 8. But penicillin molecules are highly sensitive to alkaline pH because penicillins, if exposed to alkaline pH, they get converted to penicilloic acid. Therefore, it is better that the fermentation broth is harvested before the pH becomes alkaline. The final yield of penicillin would be approximately 1500 international units per ml. This is just approximation. The highest yielding strain it gives 1500 international units per ml. So as the penicillin is highly sensitive to acidic and alkaline conditions, the pH during the fermentation has to be kept constant. There has to be continuous addition of calcium and magnesium carbonates in the medium and addition of buffers. So addition of neutralizing agents as well as addition of buffers is required for the continuous maintenance of constant favorable pH. Now, there are several workers who have suggested that even if lactose is not there in the medium, glucose addition will do. But this glucose is added very slowly in the medium. That means the slow addition of glucose in medium, it gives similar yields of penicillin. Alternatively, some workers have suggested that lipid nutrients such as fatty oils like lard oil, soybean oil, linseed oil, and long chain fatty acids that is having a carbon length greater than 14. So, all such compounds are not easily metabolizable. So, these are also utilized by the fungus and leads to good production of penicillin. Oils will also serve as antifoam agents. So these nutrients increase both yield and mycelium. So these are the alternative ways by which the production medium it can be modified. This is the graph that shows the course of penicillin fermentation. We can note here that on x-axis it is time, on y-axis there are different parameters like penicillin yield, concentration of sugar and pH. We can note here that this is the pH scale 2, 4, 6, 8. We can note the change in pH. Initially it is constant, then it rises, then again it remains constant. This is the period during which there is maximum synthesis of penicillin, and then it will start rising due to autolysis. This is the course of production of penicillin. In the beginning, there is no penicillin production due to lag phase, that During this phase, the penicillium, mycelium are growing, and there is utilization of glucose. This is where the lactose is being utilized, and there is maximum synthesis of penicillin, which goes up to 1500 international units per ml. This is the sugar depletion graph, total sugar. So total means glucose plus lactose. So initially there is gradual decrease in sugar concentration that leads to the production of penicillin. Then the recovery of penicillin. After the fermentation is over, the culture broth is first filtered, and it is filtered on a rotary vacuum filter to remove mycelia and other solids. Second step is separation of penicillin from the aqueous medium, that is from water. There is an interesting property of penicillin that penicillin in anionic form, if you see the structure of penicillin, it can be in the form of COO minus. So penicillin in its acidic form, that is in anionic form, it is solvent extractable. That means it is maximally soluble in such solvents, suitable solvents, than aqueous. So the pH of the broth is decreased to acidic, that is 2 to 2.5. So bringing down the pH to 2.5, it leads to conversion of penicillin into penicillin minus, that is anionic penicillin. And this anionic penicillin, it can be extracted by using solvents like butyl acetate, methyl isobutyl ketone, or amyl acetate. So what are the conditions here? First, penicillin is converted to anionic form, that is by the addition of phosphoric acid. The pH will go down to 2.5, and these operations are to be carried out in cold conditions, because we have already learned that the property of penicillin is that acidic conditions will destroy penicillin. But here in this case, due to low temperature, that is 4 degrees Celsius, these operations are carried out at 4 degrees Celsius, and this will protect the destruction of penicillin from acidic pH. This solvent extraction process of penicillin is done in a specialized equipment called as Podbilniak counter current centrifugal extractor. We have learned about Podbilniak centrifugal extractor, which is one of the devices which is used for counter current extraction of penicillin. So separation of solvent enriched with penicillin is separated from aqueous phase. So penicillin will leave water and it will enter into that solvent. After this first extraction, back extraction in water, that means penicillin is first extracted in solvent. From solvent again it is extracted into water. From water again it is extracted back into solvent. So these are the different shifts between water and solvent. What will happen because of this? That the impurities will remain in water, impurities will remain in solvent. So this shifts in water and solvent, it will help in the purification of penicillin. This is how the centrifugal extractor operates. We have already learned about the design of this Podbilniak centrifugal extractor. You can see here that this is the rotor, the big rotor, having these compartments, vessels, having these tubes, and these tubes are uh, opening at particular, they are attached to the central shaft of the rotor. So, and they differ in their lengths. So we can see that the this equipment is basically useful for the separation of two liquid phases, heavy liquid phase and light liquid phase. So heavy liquid phase, it is allowed to be enter in this centrifuge through center. Light liquid phase is allowed to enter through the periphery, so that when this centrifuge it runs due to centrifugal force, what will happen, that the light liquid which is fed at the periphery here, it will be forced inside, it will enter inside, and heavy liquid phase which is fed through the center of the shaft, it will be pushed outside. So light liquid is running inside, heavy liquid is running outside. So there will be a counter current mixing, and at the end this heavy liquid, it will be collected from the periphery, and light liquid, it will be collected from the center. That is the theory. Now this is the point where from where the penicillin broth will enter. Yes. So the aqueous broth of penicillin, it is feed at the center of the shaft. So it will enter through these tubings, and whenever the centrifuge runs, it will be going from this area to outside, and this is the end from where light liquid, that is solvent, is going to enter, that is through periphery. So this is attached to a pipe, and that will take this solvent from here, and it will enter inside, it will be forced to go inside by centrifugal force, and this is from where the solvent is going to come out, that is light liquid out from the center. Now here, due to counter current interaction, the solvent which is coming out, it will be enriched with penicillin, and from the other end there will be release of aqueous broth. This is how these operations are repeated several times. It is not that it is a one time operation. Fresh, so this aqueous broth, it may still contain penicillin, so it is again used to feed from this end, and there is addition of fresh butyl acetate. So these rounds, there are several rounds of these extraction process that leads to obtain penicillin into this solvent. Then in final extraction, this final extraction is done by addition of sodium hydroxide. So this sodium hydroxide will convert this penicillin to sodium salt of penicillin, that is sodium penicillin. So this crystalline penicillin salt is separated and it is washed and dried. The remaining solvent, it will be recovered and it will be reused. This is the flow sheet for production of penicillin. So the first step is the spores from the working stock. They will go to sterile wheat bran nutrient solution, incubation for 5 to 7 days for heavy sporulation at 24 degrees Celsius, and these pre-germinated mycelial inoculum, it will be used to inoculate the production tank. This is the composition of production medium: lactose, constip liquor, glucose, calcium carbonate, then certain salts, edible oil, minerals. Most important is the penicillin precursor, and this is an aerobic fermentation, submerged aerobic fermentation that requires continuous agitation, pH and temperature. After the fermentation is over, the fermentation broth will go to basket centrifuge, or there may be use of rotary vacuum filter that will separate insoluble impurities like mycelia. These mycelia are washed several times and the wash water will return back to the main tank. Then this broth is acidified with phosphoric acid and the broth is chilled to 0 to 2 degrees Celsius. The pH is brought down to 2.5. Now it is solvent extractable. So this will go to Podbelniak centrifugal extractor, where there will be addition of solvents like butyl acetate, amyl acetate or chloroform. So we have already learned these shifts are required. Then there will be back extraction from the solvent in water at pH 7 to 7.5. That is the second extractor. Then solvent will be separated. Again, these processes can be repeated twice or thrice using the same protocol as it is used here. It can be repeated here. And finally, the extraction is done using water containing salt, so there can be addition of sodium carbonate, calcium hydroxide or calcium carbonate, so that penicillin will get converted into salt form. Then this penicillin salt is separated by the suitable centrifugation or filtration technique. Then this purified penicillin is freeze dried. So freeze drying, it is a method of concentration where the water from this preparation is removed so that the concentration of penicillin, it can be increased. So this will lead to the formation of penicillin salt in powder form, and finally we get crystalline penicillin salt, which is ready for the packaging. It is packed in proper doses in sterile vials and then they are marketed.